going to Maxwell equations. Let's see the significance of Maxwell equations. So in thermodynamics, unmeasurable quantities can be replaced by measurable quantities. Unmeasurable quantities can be replaced by unmeasurable quantities by using Maxwell equations. So generally these Maxwell equations are partial differential form, the partial derivative form of the fundamental property equations. Where we stop the fundamental property equation, then starts the Maxwell equation. The end of the fundamental property equation starts the Maxwell equation. So these Maxwell equations are very useful in replacing unmeasurable quantities by measurable quantities. What are the unmeasurable quantities and what are the measurable quantities in thermodynamics? Yes, enthalpy, internal energy, element free energy, Gibbs free energy, all the unmeasurable quantities. What are the measurable quantities? Temperature, pressure, volume, pressure. So now look at the steps involved in the derivation of the Maxwell equation. The first step is just energy equation. Energy property equation. Energy property equation. This is the first step of the. Don't write down, just all of you look at these steps. First, energy property equation. Then second step will be exact differential form. Exact differential form of this equation. The second step. Third step will be the exact fundamental form. Exact differential fundamental property equation. Fundamental property equation. Then the partial derivative form. Partial derivative form is called Maxwell equation. Is called Maxwell equation. These are the four steps involved in the derivation of Maxwell equations. Energy property equation, exact differential form of the energy property equation, exact differential fundamental property equation, then partial derivative form and Maxwell equation. Let's see the first. Let's apply the Maxwell equation for third fundamental property equation. This is the energy property equation. Energy property equation means all energy forms. A, U, Ts. Ts is entropy, U is internal energy, A is the atmosphere. Then exact differential form. dA is equal to du minus d of Ts. This is called exact differential form. Then exact differential fundamental property equation. Equation 2 can be converted into fundamental property equation. Fundamental properties means pressure, volume, entropy, T. This is called exact differential fundamental property equation. Then partial derivative form. Then from this equation we need to derive the partial derivative form. We need to derive the partial derivative form. That is called Maxwell equation. Clear? Okay. So there are four types of fundamental property equation. In the same way, there are four Maxwell equations. the first Maxwell equation in terms of internal energy equation. So now let's take the steps for the Maxwell equation. What is the energy property equation for internal energy? Energy property equation, delta U is equal to Q minus mv. This is the energy property equation for internal energy. First step is completed. What is the exact differential form of this equation? What is the differential form of this equation? du is equal to dq minus dw. Second step is also completed. Second step is also completed. Exact differential form. Then exact differential fundamental property equation. Third step, du is equal to what is the exact differential fundamental property form of dq pds minus pdv. This is already derived in the fundamental property equation. Third step is also completed. Exact differential fundamental property equation. Now partial derivative form. Let's apply the partial derivative form for this equation. This is a very crucial step in the derivation of the Maxwell equation. So dou T by dou V. Let's apply the dou. Partial derivative form means let's apply the dou. Dou T by dou V is equal dou P by dou S. There is a minus sign, we should add minus sign here. There is a minus sign, we can add minus sign. It is a constant entropy, this is a constant V. This is called the partial derivative form. Dou T by dou V at constant entropy is equal to minus dou P by dou S at constant volume. Done. Maxwell equation is finished. This is called Maxwell equation. Maxwell equations are always in terms of partial derivative form. Let's apply the dou. Dou apply it. Exact differential apply it. D apply it. Partial derivative apply it. Dou apply it. Dou T by dou V. Dou T by dou V is equal to dou P by dou S. This is called partial differential. Actually, each step to 20 steps on mathematical equations. This is not. Those all 20 steps are skipped. Those are not necessary, those are not important. For a biology students, you may not understand all these 20 steps. That's why all these unnecessary steps are skipped. So directly I am writing Maxwell equation. Easy way. This is the shortcut form. Dou T by dou V is equal to dou P by dou S. So what is the significance of this equation? If you want to determine the internal energy, you should know the four measurable quantities: temperature, entropy, pressure and volume. By Maxwell equation, if you know any two, either T, P or Ps, if you know any two properties, either temperature, volume, we can measure the du directly. This is du equal. Or if you know P and S, you can estimate du directly. Four properties are reduced to two properties by using Maxwell equations. మీకు T గాని P రెండు తెలిస్తే at constant entropy you can measure du directly. Four properties, two properties reduce చేసాం. That is the beauty of this Maxwell equation. By using Maxwell equations, if you know temperature and volume, you can measure du directly. Or if you know P and S at constant volume, you can measure du directly. Okay. first Maxwell equation for estimation of internal energy. Now let's see the second Maxwell equation.